and welcome to the Old Gazer channel. So called because I'm old and I'm a gazer, as in stargazer, which of course means that this channel is all about amateur astronomy, and specifically it's designed for beginning or inexperienced amateur astronomers. The goal of the channel is to try to offer some practical advice and some information and a little bit of inspiration that might be of help to you as you work your way through this very wonderful but sometimes intimidating hobby of amateur astronomy. So welcome. Glad to have you. If this is your first video, welcome. If you're returning, welcome back. And let me just say this before we get started. Those of you who've been watching the channel and have seen some or all of my previous videos will know that it's been a long time since I've posted a video, and you might have wondered if I had dropped off the face of the earth or gone, belly up or whatever, but as you can see, I haven't. Just a word of explanation. I decided to take a little bit of a sabbatical, so to speak, from doing the videos for the channel because I had gotten myself in a situation where I was proceeding at a pace that was just not sustainable. I was churning out one of these videos about once a week for quite a while, and I should have known from the beginning that that just wasn't practical for me to do that. I'm an older guy, no great secret there, and I'm still working full time. My wife and I own a small business, and I'm putting in 50 to 60 hours a week there. I've got 5 grandchildren that I like to spend time with. I've got a lot of things going on, and it was just a little bit too much for me to do those videos as often as I was doing them. There's quite a bit involved in doing one of these. This is a strictly amateur production, which you're certainly aware of as well. But still, there is the requirements to prepare for the video, to do a little editing, and then to get it uploaded to YouTube and so forth. So I just needed to back off a little while, and as I said, sort of take a little sabbatical for a couple of months. And so that's what I did. So I apologize if you've been looking for another video and haven't seen one. And there might have been some comments posted to some of the videos that I haven't seen and responded to since I've backed away a little bit, and I apologize for that. But I'm back, but things will be a little different going forward. The videos are not going to be posted on a regular basis, and they'll be infrequent. I'm not sure just how infrequent they're going to be, but I'm going to have to work this into the rest of my life as best I can. I'm not going to quit, though, because I enjoy doing the videos very much. And based on the number of subscribers and the number of views and especially a lot of the comments that I've received, apparently I'm doing a little bit of good and making a little bit of a difference, at least, in helping newcomers or inexperienced amateur astronomers move through the hobby. So I'm going to keep going. You'll expect to see me when you see me, so to speak. And the videos will keep coming just on an irregular basis, and probably not very frequently, because I just don't have the time or energy to keep up that pace of doing once a week or that often. So just that word of explanation. And all of that said, let's just move on, shall we? So what are we going to talk about in this video? Well, let me start out by saying this. It's been my experience over the years in being involved with amateur astronomy that people get involved with this hobby for different reasons. Some people are attracted to the technical aspect of the hobby. They love telescopes and accessories and all the telescope gear and everything, and that's their primary draw to the hobby, and there's certainly nothing wrong with that. I like gear and the technical aspects of the hobby as well. Nothing wrong with that. There are people who get into astrophotography, and they're drawn to being able to produce really good pictures of deep sky objects. It's at least as much an art as it is a science to many of those. And that's a wonderful pursuit, and there's certainly nothing wrong with that either. But I know it's true of me personally, and I know it's true of some others as well, that sometimes we fail to give proper attention to just sitting back and reflecting on what we're doing and think about these wonderful objects that we're viewing out there in the night sky, and just pausing to consider what they are and how awesome they are, and what implications their existence might have for our existence in our lives. They're wonderful things, amazing things. And so I want to emphasize in this video the importance of staying close to the objects, not just enjoying our telescopes, not just enjoying taking pictures, not just enjoying trying to look at some object in the night sky, but to appreciate these things that we're looking at, and to make sure that we're studying them and coming to understand and appreciate their significance, their vastness, all of that. It's just a very important aspect of the hobby, in my opinion. So in that spirit, in this video, I want to talk about one of the classes of deep sky objects that most amateur astronomers eventually get involved in trying to observe or photograph. And that is star clusters. We're going to talk about star clusters in this video. That's something that's been very important to me over the years. I really enjoy viewing and imaging and studying star clusters. There's something about them that seems to just really speak to me. They're beautiful, they're majestic. And when you learn something about them and understand what they represent and what you're looking at when you're studying one of these star clusters, that's where the significance really starts to come to bear. And that's what I want to try to emphasize in this video. So what is a star cluster? Well, it's just what the name implies. It's a cluster of stars. It's a group of stars that are clustered closely together into a cluster. As opposed to, the stars that are just scattered seemingly at random all over the night sky, we can find certain stars, that are obviously drawn together in clusters. And that's fascinating in and of itself. But when you stop to realize what these clusters actually are, it gets really interesting. So we're gonna talk about those star clusters, and we might as well start out by saying, what causes stars to gather together in clusters to begin with? It's really no big brainer there. By the way, this is the perfect place to say that, just like all my other videos, this is going to be a highly simplified discussion of star clusters, because I'm a simple guy and that's what I do, and it wouldn't be proper to try to get into any kind of technical details anyway. The math, or to drill down and try to look at the real detailed technical aspects of star clusters for people who are just beginning the hobby, and you're just an amateur astronomer. So let's not get into the nuts and bolts. If you want to learn all there is to know about star clusters, you certainly can do that. And you can go elsewhere for that, because this is going to be a highly simplified overview of star clusters. So I'm going to give you a resource here at the beginning of the video that you can go to as a starting place to do a more detailed, more intense research on star clusters. That resource is a website, and it's cfa.harvard.edu. Now, the CFA there stands for Center for Astrophysics. And of course, it is a Harvard website, so we're going to get educated when we go to that site. It's not detailed, at least parts of that website are not detailed. There's a very good overview of star clusters on there, given in terms that most amateur astronomers can understand and relate to. If Old Gazer can understand it, you certainly can understand it. So that's a good starting point for you if you want to learn more about star clusters. But I'm just going to give you an oversimplified summary of star clusters in this video, and so let's get back to it now. Star clusters. What causes stars to cluster together to form these star clusters? Well, it's very simple, really. There are, as you know, nebulae out there in space, interstellar clouds of gas and dust and whatever other materials might exist out there. And that represents the raw materials from which stars are made. The matter within these nebulae are brought together by gravitational attraction, and that's kind of a snowballing effect, and eventually a star is born when that process goes through to completion. Well, it so happens that in nebulae that are pretty dense, that have a lot of material to be used as raw materials in star formation, there's never just one star that's formed out of that. There's always a multitude of stars, a group of stars. And those stars, for some period of their lifetimes, are going to stay clustered pretty close together because they came from the same point of origin, that nebulae. That nebula that provided all the raw materials that went into the stars. So the stars in their beginnings cluster together. Some of them stay clustered together basically, for all practical terms, forever, because they become wrapped up in gravitational attraction from which they can't escape. Others are not so tightly bound, and they over time will drift away from the cluster until finally there's no cluster left. But anyway, just stars being born in the same vicinity, out of the same nebula, out of the same material, are drawn together and clustered together in these things we call star clusters. Okay, now for us amateurs, there are basically two different kinds of star clusters that we can view and that we can photograph and that we can study. Let's talk about those each in turn. The first one I want to talk about is called an open cluster. Open cluster. Now, an open cluster is a relatively small cluster of stars. It might be anywhere from, let's say, roughly 10 or a dozen, all the way up to several hundred. Open clusters don't have any symmetrical pattern about them. Their shape, their distribution of stars is very irregular, but they are clustered close enough together. And most of the stars in an open cluster were born or came into being at about the same time. So they're the same age and many of them the same general appearance. So that's an open cluster. Now, most of these are located near the bulging disk of the Milky Way galaxy. And so they're in a high traffic area, if you will, insofar as the space within our galaxy can be a compact high traffic area. And over time, the stars in these open clusters will be affected by various things. Other passing stars, contact with or close proximity to other star clusters, collisions between star clusters perhaps. Whatever it is, there are a number of factors that can cause stars to escape the cluster and just become individual stars outside the cluster. And that's what happens with open clusters over time, so that eventually the stars will no longer be in clusters, they'll be individual stars out there. Now, for that reason, you won't find any open clusters that are really old, at least by, the standards of the cosmos. Most open clusters are less than 1 billion years old. You're saying less than 1 billion years old, that's really young. Well, yes, it is when you consider that our universe is 13 or 14 billion years old. Less than 1 billion years is a relatively short period of time. And open star clusters are believed to not exist for much longer than that, because by that time, all of the member stars will have escaped the cluster and, gone out on their own. They will have left the nest, so to speak. So that's kind of the nature of open star clusters. Now, there are approximately 150 open star clusters known to exist in the Milky Way right now. But that's the number that we know about. And astronomers believe there are probably many, many more than that. But since they tend to live close to the galactic disk, the bulge of the disk, and more towards the center of the galaxy, they're hidden. They're hidden from view and can't be seen very well. But they're discovering more and more over time, and I'm sure there will eventually be many, many more open star clusters discovered within our galaxy. Now, there are, I believe I'm correct in this, haven't checked it recently, but if memory serves, there are, I believe, 29 open star clusters included in the Messier Catalog. Now, for those of you that don't know what the Messier Catalog is, let me refer you back to a previous video that I did. The video was called How to Find Deep Sky Objects. And in that video, we went into some length describing the Messier Catalog and what it is and how to use it to good advantage to find objects in the night sky and to learn about them. Well, it's a list of 110 deep sky objects, galaxies, nebulae, star clusters, which were put together back primarily in the 1700s by an astronomer named Messier, and then they've been modified and added to a little bit over the years by a few other people until today. That Messier Catalog contains 110 objects, and that's a very good basis or framework within which beginning amateur astronomers can work. That gives you a good range of deep sky objects that are, many of which are within reasonable reach of amateurs using amateur telescopes. And so, the Messier Catalog is just a standard, well known and well used by amateur astronomers everywhere. And in that Messier Catalog, it turns out that 29 of those, I believe it's 27, the more I think about it, maybe 27, 27, 28, 29, 20-something of the objects in that 110 object Messier Catalog are open star clusters. And some of these are pretty easy to find and view and photograph and study. And as a matter of fact, there's at least a couple of open star clusters that you can see with your naked eye, even in areas with very significant light pollution. Others you'll have to have a telescope to see, but you can see a lot of these clusters with an amateur telescope, the open clusters. Very beautiful. And very interesting and very appealing. And, and as we find and view and photograph and study these clusters, the thought that I would like to plant here is that don't just find them and look at them or take pictures of them. Consider what they are. A cluster of stars born out of the materials within a nebula, clustered together, young stars for the most part, many of them very similar in terms of their age and in some cases their composition, short-lived clusters for the most part that eventually will get torn apart by all the other forces at work within our galaxy until the cluster basically is no more, that occurring in less than 1 billion years typically. Just thinking about what these things are, how vast they are, how far away they are, what their significance is in the evolution and the star-making process within our galaxy, and of course their beauty. There's some of these open star clusters that are very, very beautiful, but those are open star clusters. The best thing to start with, open star clusters, when you're beginning to consider star clusters in general, because they're easy to find, they're easy to see. Most of them fall easily within the field of view of amateur telescopes. Just a very interesting and wonderful thing to pursue. That is the observing and the imaging and the studying of open star clusters. Let's break away here right now for a few minutes, and I want to show you just a couple of open star clusters to give you an idea of what these are. One of them is a very famous one. One of those that you can see with your naked eye, the other not so famous, and one that you'll have to have a telescope to see in most cases. But let's just take a moment here and look at a couple of open star clusters, talk about those a little bit, and then we'll come back and continue after that. Okay, let's take a look at a couple of open star clusters here. You'll probably recognize the one that's on the screen right now as the Pleiades, sometimes called the Seven Sisters and designated M45 in the Messier Catalog. This is probably the best known of the open star clusters. It's visible in most circumstances to the naked eye in the constellation Taurus. Now, this is not a very good picture here. It doesn't do it justice, but I don't call myself the poor man's astrophotographer for nothing. I only do things so far and no further when skill and runs out and equipment becomes limiting. But actually, it's not so bad considering that this is the second picture of a deep sky object that I've ever taken. Second only to my first attempt, which was to get an image of the Orion Nebula. So we'll use this as our picture of the Pleiades star cluster. Let's talk a little bit about it. It's 444 light years away, and that probably helps to explain why it's one of the more prominent open clusters. It has hot blue luminous stars. And it's believed to be about 100 million years old, and astronomers believe that it'll probably continue to exist as a cluster for about 250 million more years, at which time it will have been dispersed by gravitational interaction with things it comes in contact with or passes near to within our galaxy. So of course, unless the wonder of wonders happens, unless there's something of truly epic magnitude that takes place, none of us will be around to see the demise of the Pleiades. But at any rate, its total life is expected to be about 350 million years, which is fairly typical for open star clusters. Now, if I had a better photograph, longer time exposures, you'd be able to see some very beautiful blue nebulosity around the stars. It was formerly thought that was actually a nebula that was part of the cluster, maybe the what's left over from the nebula that created these stars to begin with. But the prevailing opinion now is that it's just simply interstellar clouds of dust and gas that the Pleiades are passing through on its way through space, and glowing blue from the reflected light from the bright blue stars within the Pleiades. It has over 1,000 statistically verified stars, and its total diameter is about 43 light years. Just a very beautiful open star cluster, and let's consider over and above the factual information that we've just discussed. It's very interesting to pause and just reflect upon what we're looking at here and what we're thinking about. The grandeur of it, the cosmic scale of it, the vastness of it, the distance away, the age. But primarily just the beauty and the fact that this is a beautiful part of this universe in which we live, and something that's highly significant, therefore, and something worth our time to stop and admire and ponder. And I urge you to go out and hit the internet or books or whatever media that you choose and learn some more about the Pleiades. Moving on, what you see on the screen now is a photograph of an open star cluster known as the Wild Duck Cluster. Has a Messier designation of M11. It's called the Wild Duck Cluster because one of the first people to look at it back in the days when they first started being able to resolve stars in these clusters through telescopes, he thought that the V-shape stars here reminded him of a flock of flying ducks, so it got the name Wild Duck Cluster, and that's kind of stuck. And The Wild Duck Cluster. It's in the constellation Scutum, or the Shield, and it's one of the richest and most compact of the open star clusters. It looks almost like a globular cluster, but it is an open star cluster. It's believed to be about 300 years old, 300 million years old, more or less. It's about 6,000 light years away. I have some conflicting information about how many stars are in the cluster. I've seen everything from 1,900 to about 3,000, so somewhere in that range. I'm going to have to pick up the pace here a little bit, so I think we've probably heard enough about the Wild Duck Cluster. Just one of the more interesting open clusters to look at because it's kind of unique. It's tightly clustered and compact and very rich. But let's move on. By the way, I'm going to have to pick up the pace here, or this is going to wind up being my longest video yet. I had a comment on a recent video from somebody who had viewed one, and he just had two simple words in his comment, which were verbose gazer. I guess he considered me to be, instead of the old gazer, a verbose gazer, and I cannot disagree with him. I don't doubt that he's right. I probably am verbose, but I'm old and hard to change my ways, so I guess long videos is just something that everybody's going to be stuck with as long as they stick with the channel. But anyway, that is a very brief overview of the Wild Duck Cluster. All right. I hope that was instructive or helpful to you. With that said, let's move on now to the second major category of star clusters that we want to talk about, and that would be the class called globular star clusters. Now, globular star clusters are very different from open star clusters. They consist not just of a few stars, but many thousands of stars, many hundreds of thousands of stars, even in some cases millions of stars, all clustered together. Globular clusters, as the name would suggest, have relatively defined spherical shapes, generally speaking, rough spheres anyway, or they're globular in configuration. So they're different in open clusters in that way. Open clusters are irregular in their composition. A globular star cluster is grouped together basically in a spherical arrangement of stars. Now, globular star clusters typically are bound together by gravitational force, and they will remain that way. They don't have a short life, by universal standards, by the standards of the cosmos, like open star clusters do. As a matter of fact, some of the clusters, the stars within the globular star clusters, are among the very oldest stars in our galaxy and among some of the oldest stars in the universe. Some of them are billions of years old. And they're not going anywhere. They're going to remain that way unless something cataclysmic happens to break them up. Globular star clusters are also formed from nebulae out in space, from gases and dust and interstellar space coalescing together to form stars. And if there's enough of that raw material, more and more and more stars will be formed until there are enough of them, a large number of them, and they become bound gravitationally, and the result will be a globular star cluster. These tend to be more in the outer regions of the Milky Way galaxy, and they've been there for a very long time, most of them, and they'll be there for a very long time to come. Among the oldest stars in our galaxy. Now, at one time, it was believed that all of the stars in one of these globular star clusters were from the same generation of stars, that they were born at about the same time out of the same interstellar nebulosity, and that there was basically a generation of stars there. I believe the more current thinking is that there's not just one, but perhaps several different generations of stars within globular star clusters. Now, how can that happen? Well, I don't pretend to understand it all. But from what I've read, some things can happen over time. A globular star cluster, as it's moving through space, can encounter another area of nebulosity. More stars are being formed, and because of the close proximity to this cluster, they also become a part of it. Maybe clusters over the long eons of time collide with one another. Who knows? But at any rate, globular clusters, very old, not going anywhere anytime soon, and containing hundreds of thousands, typically sometimes millions of stars gathered together. Now, I believe that there are approximately, more or less, ballpark, about 1,000 globular star clusters that have been discovered and identified within our Milky Way galaxy. But here again, astronomers are convinced that there's probably more than that. Obscured for now, not visible. Many, many more almost certainly will be discovered in time to come. There are also 20-something globular star clusters among the 110 objects in the Messier Catalog. Now, I don't believe you can see any globular star clusters with your naked eye. It may be in very dark skies, and if you've got very good eyes, you might be able to just make out a hint of a few of them. I've never been able to do that. I'm old, my eyes are not what they once were, and I also live in an area where there's very significant light pollution. I live in an area of Bortle 5/6 skies. I've never been able to get a glimpse of a globular star cluster just with my naked eye. As a matter of fact, here where I live, under these kinds of light pollution conditions, when I look at a globular star cluster through my 8-inch telescope here, which has pretty decent light gathering capability, all I can see basically is a gray smudge in the field of view. I can't resolve any individual stars. It just looks like a gray smudge. I can see it. I definitely know something is there. But the only way that I've been able to actually resolve stars in these globular clusters, given my equipment and given where I live and the amount of light pollution here, is to take long exposure photographs of them and collect as much light from them as I can, integrate numerous pictures together into a stacked image and edit that, and then I can see many of the stars in these globular star clusters actually resolved, and you can see the beauty of that globular star cluster. And if you live in dark skies and you've got an instrument with perhaps even more aperture than this one, you might be able to view them and see them very well. They're spectacular sights. They've always seemed to me, when I've looked at them in the photos that I've taken, majestic, very beautiful. If you're fortunate enough, you can sometimes capture different colored stars within that cluster, and that makes for a very interesting image as well. So here again, as we talk about these globular star clusters, they're not just beautiful things that we can see or photograph, pinpoints of light out there and gathered together in a cluster. They're much more interesting than that. What strikes me every time I look at one of these in a photograph that I've taken is, I get this overwhelming sense of age. That's far too mild a word for it. Ancient also is inadequate. I mean, these globular star clusters are extremely old, containing some of the oldest stars in our galaxy, stars that are literally billions of years old. I've read that some of the globular star clusters in the Milky Way galaxy may have stars that are approaching 12 or 13 billion years old, which is getting very, very close back, to the origin of the whole thing. But, that overwhelming sense of age, of realizing that I'm looking at something that's billions of years old, just as it can be almost overwhelming. It can be humbling, overwhelming. It can really put a perspective on things that few other things can. And, I think it's worth thinking about that when you're trying to observe or image and study these globular star clusters, to be able to appreciate what you're really looking at there. They're far away too. I mean, it never fails to amaze me that, these are at varying distances from us, of course. Some of them are long, long, long ways away, on the order of perhaps 80,000 light years even. And to think that the photons from this that are striking my eye, or that are being, impacting the sensor in my camera, started their journey 80,000 years ago, or 30,000, or even 500 years ago. Still another almost incomprehensible indicator of the vastness of this cosmos in which we live. So, these things are amazing. They're awe-inspiring. They're worth just sitting back and thinking about and contemplating and reflecting on and studying more about. And again, starting with the resource that I gave you, I would urge you to go read more about star clusters and learn more about them. And as you do so, don't forget to stop and pause and think about the enormity, the enormous significance of what it is that you're studying, what you're looking at, what you're taking images of. Star clusters are amazing, amazing things that almost defy the bounds of our imagination. And yet there we have it right at our fingertips, either through the eyepiece of a telescope or on a photographic image that we've taken. There we have that vastness available for us to look at and to contemplate and know that we have seen an image of that with our very own eyes. So, I hope I've inspired you a little bit. Let's pause here again, and let's take a look at a couple of globular star clusters, and we'll talk about that a little bit, and I'll be back then with some closing comments at the end.
Okay. This is a photograph of one of the most spectacular, easily observable globular star clusters for those of us here in the northern hemisphere. This is known as Messier M13, sometimes referred to as the Great Globular Cluster in Hercules, or just the Hercules Cluster, because of course it resides in the constellation Hercules. Very beautiful. I took this picture. There's much better pictures out there, but this one gives an indication of its appearance through a modest amateur telescope. So that is M13. Now let's talk about it a little bit. M13, of course, very, very old, and it'll be around for a very, very long time to come. It's about 25,000 light years away. And it contains hundreds of thousands of stars. The most current estimates are range between 300,000 and 500,000 stars in this amazing cluster. It's about 145 light years in diameter. It has an apparent magnitude of 5.8, which means if you live in dark enough skies, you should be able to just glimpse this as a fuzzy patch with your unaided eye. Here where I live, I wouldn't even come close to being able to see it. Even through my 8-inch telescope, it only shows up as a fuzzy patch. I have to take long exposure photographs to get the image that you see here. So just an amazing, amazing thing. Very ancient. You're looking at some stars that are billions of years old, 25,000 light years away, containing perhaps 500,000 stars. And just a very, very beautiful object, and one that's leaves you with a profound sense of amazement when you contemplate just what it is and its significance along with all of the other globular star clusters out there. So we'll stop there. Just wanted to give you that look at the Great a globular cluster in Hercules M13. This is the final example I want to show you of star clusters. This is the globular star cluster M5, which is located in the Serpens Caput constellation, which is sometimes called the Serpent's Head. Very spectacular, just like the previous one that we've seen. This one, M5, also about 25,000 light years away. It's about 165 light years in diameter. The estimated number of stars ranges from 100,000 up to 500,000. It's estimated to be about 13 billion years old. Now that really shocked me when I read that. That's 2 times the age of our solar system and almost as ancient as the universe itself. So if that doesn't really sort of humble you and make you wonder and just gaze in wonderment at it, to think about how ancient that is, it's just amazing. Now this one, it doesn't look as big in this photograph as M13 did, and that's because they were taken with 2 different telescopes. M13 was a picture taken through with my 8-inch telescope. This one of M5 was taken with an 80 millimeter refracting telescope that has a much greater field of view. And just wanted to give an idea here of, sort of a different look at it, but you can see it sitting right there in the middle of the screen. Just very spectacular and worthy of our appreciation and, invoking a sense of awe and, just wonder. I don't know what else to say about it except that it's an object of great wonder. So that concludes the examples of the star clusters that I wanted to show you, and now we'll have a final word and wrap this one up.
Okay. I hope that was enjoyable. I hope that this video has inspired you a little bit to want to get out there and find these globular and open star clusters in the night sky. Look at them, appreciate them, view them, image them, or whatever, and above all, understand their significance, understand the scale of time and space that they represent, and just understand their magnificence is all I'm asking. That's a big part of this hobby that can really add to your hobby when you bring yourself to the point where you can appreciate those kinds of things about these unbelievable objects that we are viewing, studying, and imaging in the night sky. So I hope that's been a little inspirational. I hope you can put this information to use. And we'll talk about some other objects in a similar vein in future videos. But for now, let's call it quits for this one. It is good to be back again. I do enjoy doing these videos, and evidently I'm getting some good positive response to them, which is what I'm hoping for, in the sense of helping people who maybe don't know a whole lot about this hobby but want to know more, just the basics from the ground up. So it's good to be back. Thank you all so much for very much for watching. And as I conclude all my videos, let me just close by wishing all of you clear skies and good viewing.